Hello guys, my name is Aniket Singh and today we are gonna talk about numbers. Well, when I was young, I always thought what's the biggest number? Is it a million? A Googleplex? Well, however big of a number I thought, I could always add one. So there isn't any such biggest number? Well, maybe. Except infinity? No, infinity isn't a number. It's actually a concept to compare things that are unending. We know natural numbers starts from 0, 1, 2, 3, 4 and so on. But how many naturals are there? Well, there's a unique name for it, the Aleph Naught. Aleph Naught is the smallest infinity. It is also the number of even or odd numbers there are, and also how many rational numbers there are. The point is, Aleph Naught is a big amount, bigger than any finite amount, but we can count fast. Let's consider a set of infinite lines. Now, each line represents a natural number. So, there's always an extra line when there's an extra number. The cardinality of this set of lines and the set of natural numbers is Aleph Naught. Now what happens when we add an extra line outside the set? Is it Aleph Naught plus 1? No, we still have Aleph Naught number of lines, as we still can pair them one by one starting from this new line. We can even add 2 or more or even another Aleph Naught number of lines, and still the quantity remains same. Okay. Let's go back to the single line after the set of infinite lines. Now let's number each line according to the order it was drawn. So we will start here and go left to right. Now what's the number of this line? In order to number this line, we need a set of labels of numbers past the naturals. We need ordinal numbers. The first transfinite ordinal is omega, followed by omega plus 1, omega plus 2 and so on. But omega plus 1 isn't bigger than omega. It just comes after omega. Aleph Naught isn't the end. There are infinities bigger than Aleph Naught. The power set of Aleph Naught is bigger than Aleph Naught. Repeated application of power sets can produce bigger and bigger infinities. This can be done by Cantor's diagonal argument. The point is, there are bigger infinities than Aleph Naught. There's just one problem. With the help of axioms, the axiom of infinity can help us here. All we need to get omega is say that there is omega. That much. Eventually we will get across to omega plus omega or omega square. But it will create another infinite set. The axiom of infinity can't help us here. We need a greater axiom. The axiom of replacement. This axiom states that we take all the orders up to omega and place omega plus 1 in front of each. Now we have reached omega plus omega or omega square. Eventually we will reach to omega to the power, omega and so on. Further replacements will create bigger and bigger infinities. Now look at these ordinals. There must be one ordinal that comes after each of them. This is called omega 1. The cardinal number used to describe omega 1 is Aleph 1. The power set of Aleph Naught will not be anywhere between this cardinal. It may be equal to Aleph 1 as depicted in the continuum hypothesis, but it may be larger. We don't know.